Hi everyone, my name is Gil Pasternak. I am a member of the superconductive team. We build and maintain the open source project Great Expectations, and today together we are going to be walking through the process of building an actual expectation from scratch. So without further ado, I'll share my screen and we are going to go through this tutorial. This tutorial can be found within the Great Expectations documentation under the name How to Contribute a New Expectations to Great Expectations. Now, this tutorial assumes a couple things. It assumes that you've already set up your development environment to contribute, and it assumes that you have already signed the contributor license agreement. Today, we are going to be walking through the process of building an expectation, and in the process, I will be attempting to give you guys some intuition in regard to what an expectation actually is. So starting with that, what is an actual expectation? Well, an expectation is a unit test of our data. We are basically validating some pre-existing belief that we had in regards to our data. Some examples being, is our column mean between two thresholds? Are all of our column values unique? Or do all of our column values match a particular regex? In building an expectation, we build a powerful language that can be used to validate our data in different circumstances. And today we are going to be learning how to use that language. So we'll start with really just coming up with our expectation. So in doing this, I want you guys to think about a data validation that would be useful or powerful in validating your data in everyday life, on an everyday basis with data that you usually or continuously use. So the example that I came up with for the purpose of this tutorial is expect column values to contain character. This expectation has a variety of applications. Some examples being, if we're validating a column of emails, we would like to know that all of those emails contain the @ symbol. So that could be a powerful example of that. Now, the first step, as listed within the tutorial, is we are going to choose a parent class to help our implementation. These parent classes are powerful abstraction frameworks that allow us to basically simplify the concept of building an expectation by categorizing it, by putting it into some simple subcategory. Each one of these expectations either already has or will soon have a template that you can essentially just go off of and implement your expectation from scratch. Well, using the template rather. So in our expectation, which is expect column values to contain character, the best classification of this expectation is as a column map expectation. And this is because the column map expectation practically asks a yes or no question of every single value in our column. You can think of this as the equivalent of surveying a bunch of people and asking them whether they're over 5 feet tall. So ultimately, each one of them can respond with a yes or no answer. So Jim responds with yes, Jack responds with no, so on and so forth. And ultimately, we come up with a mapping of a column of people or something of the sort, some data, into a column of yes or no answers to a basic Boolean question. So that's what a column map expectation is. Column expectations, on the other hand, are usually used for more aggregate data. Column pairs are used to compare two columns, and table expectations are kind of a generic catch-all for all other types of expectations. So in selecting our actual expectation, column map seems to be the most fitting. And this is because every single value here is being mapped to a true or false. We're asking a yes or no question of every value. Do you or do you not contain a certain character? And in asking that, we are thus mapping it to a yes or no column. So the first thing we're going to do after choosing our expectation is we're going to copy the template from our examples into our contrib directory. So we're going to go to PyCharm right here. We're going to go to examples, expectations, and as you can see here, there is a column map expectation template just waiting for us. So all we're going to do is we're going to copy it, and we're going to go to contrib experimental great expectations, and then within it, the expectations folder, that's where we're building our expectations, as you can see right here in the sidebar. And then we are going to name our expectation. We are going to name it in accordance to what we're validating. So we are validating that every single value in our column contains a certain character. So we're going to say expect column values to contain character .py. And we're going to overwrite this document. And here we are given an empty template. So now that we're granted the template, we can scroll through. Just at first glance, we've got a class here. This is a metric class. It's used for any computation. We've got our expectation class right here. We've got a docstring, which is crucial to add later before you build a PR, but we will not be adding it during the development process today. We've got some metadata, some keys, won't go over those yet. And at the bottom, we've got a run diagnostics. Now, this diagnostics report is really crucial because it creates a powerful dev loop for you to check your expectations in real time. It allows you to develop a little bit, then check the results of your tests, develop a little more, check the results, so on and so forth, thus looping. You should be running this very often while actually building your expectation. So the first thing that we're going to do within this actual file is that we are going to change all of our names to actually match what we're going to be developing. So our metric is basically what we're computing, and we're computing whether or not the column values contain our character. Then we are going to call this our, in accordance to our file, expect column values to contain character. And that's going to, as we saw before, inherit from column map expectation. Then we are going to go to the bottom and we're going to run our diagnostics from the actual expectation we're developing. So expect column values to contain character. Awesome. Okay, we built this part. Now it's time to execute our template. So we're going to run that right here in our IDE, and it will take a couple moments to run. But when it does, you'll see that I have a basic format dictionary-like test results, as we can see right here, which is characteristic of all expectations. And as we can see, the name has already been updated as expect column values to contain character. So we've got our basic format, and the next thing we're going to do is build a test. So test-driven development is at the heart of building an expectation. It's really crucial because all expectations are in essence tests. So we've got to expect something of our data prior to developing an expectation. So we've got our examples folder right here. As you can see, there is a to-do for you to add a docstring. It's very important to document your expectations prior to actually building a PR and attempting to merge those into the framework, because users should know what the expectations actually do. Now, in building our test, we are going to basically build an example that is characteristic of the way our data should behave if it passes our expectation. So we're going to expect column value to contain a certain character. Let me come up with a certain character. Let's go H. So we're going to call our test mostly H's. And then we're going to put a bunch of words here that contain the letter H. And then we are going to have a couple missing values, and then we're going to have one value here that is uncharacteristic, and we expect to fail our test. Next, we're going to name our test. We're going to say positive test would mostly actually make sense. We're going to leave this parameter as false. And then we're going to build one more parameter here, including gallery. This is crucial because it ensures that our test is actually included when we build our run diagnostics. So our column is going to be mostly H's. That's what we named it. Given that our test is going to be expect column values to contain a character, it makes sense that we give our test, or that the theoretical user gives our test in their input some character. So the character that we expect is going to be H. And then we've got our mostly parameter. The mostly parameter essentially indicates how many, or rather what proportion of our values we expect to pass our test. So here in indicating 0.6, we expect 60% of our values to pass our given test. Now, we expect it to be successful given that 1, 2, 3, 4, 5 out of our 6 values actually match. And our unexpected index list, basically the only unexpected index we have is index number 0, 1, 2, 3, 4, 5. Now, we're going to leave it as 6 just to see what happens in making a purposeful error, but we'll keep the unexpected list as notes. Now that we've built our test, we should, given that we haven't implemented anything, we should expect it to fail, but we'll run diagnostics again just to make sure that the test is now included within our framework. So once again, this will take a couple moments to run. And once it does, we will see that there is a test failure. As we can see, no definition found for a metric, which makes perfect sense given the fact that we haven't implemented anything. And now it's time to get our actual implementation in, which is really, really trivial. So the first thing we're going to do is implement our computation or our metric. So our metric name, for some reason, does not match this class, and that is something that we should fix from the template. And we are going to uncomment this implementation right here. Now, we have 3 dialects that you can actually implement your metric for SQL Alchemy to run on SQL databases, for Apache Spark to build a PySpark implementation. By today, just for the sake of simplicity, we will be implementing our metric only for pandas. Now, if a metric actually needs user inputted values, we should add something called condition value keys, which basically says, okay, this is what my metric expects from the user. And in building this, we'll say, okay, we expect the user to provide a character. And since we expect the user to provide a character, we can also have a parameter named character here, which will intake a value. And now we just build our computation. So in pandas, you can use the apply method to map a column of values using a function. So that is what we're going to do. So we're going to build a lambda function, and we're going to say character lies in X. That is our test, is our character in each value. And that's only going to hold if X is not none, because we don't want to compare none values to a string. And then we're going to say else. If it is none, we're just automatically going to write false. And just for safekeeping, we're going to convert all of our values to strings to ensure that no integer string comparisons are made. So that is our function implementation. And now all we need to do now that we've already implemented our computation, is just to make sure that our actual expectation knows where that metric or where that computation is coming from. So now that we go to our expectation class, you'll see that there's a map metric. This is where we say, hey, here's the computation that you need to use in order to obtain whatever calculations you've asked for. So we're gonna call this column values dot contain character, and I'll quickly verify that this was the metric above, and that is correct. And success keys, once again, this is our user input. We're in a different expectation class, and now we need to ask the user, hey, could you enter this, this, and this, so I could verify that your data run successfully is successfully validated by your actual test, to ensure that your data truly, for lack of a better word, follows your expectations. So in our success keys, we're going to include our character. That is the value we need to validate, because we can't expect column values to contain a specific character if we don't know what the character actually is. So now that we've done that, we can feel free to go and run our test again and see what happens. This will take a couple moments to run, but when we run it, we will see another error, and that should be the error that we have ingrained earlier to just ensure that our tests are actually running correctly. So as we can see, the test runs perfectly. However, we have a false success because unexpected list, index list, had expected a value of 6, but got the index 5. And that makes perfect sense because prior we said, okay, the index that is incorrect here is the value at index 5, which is notes. However, we put index 6 to make sure that our tests truly verify errors. So we're going to change that, and we're going to run our tests again. And within this next run, we should actually have a successful test passing. So that should be working in the next several seconds. And when we have that, we can see our test report comes back with success being true. We have fully verified that our test runs successfully. Now that you've done this, you should go back and write several more tests to verify your data in different ways, but to not take up much time. I will not be doing that. Also, please, please, please don't forget to write documentation. A well-documented expectation is much preferable to a expectation that people don't know what to do with. So once we've written that theoretical documentation and those examples, the last thing we're going to do is we are going to go to a place called library metadata within our template, and we are going to take credit for our expectation. So we're going to uncomment this. I'm going to put my GitHub handle, and we are going to put an experimental tag, and our expectation is ready to go. So now we can commit it to whatever GitHub repository we have. And we're going to commit it under the name new expectation. I'm not actually going to commit this because I don't plan on building this new expectation, but you will do so. And once you're ready, feel free to build a PR. Make sure you're following the style guidelines. And I wish everyone excellent and easy, in particular, experiences in contributing their first or their second or any number after that expectation. And I hope that you have a very, very good time using our framework for a long time after that. Thank you very much for being here with me today for this tutorial, and I wish everyone a great day.